The goal with summation problems is to try to rewrite them so that they're the sum of some variable being squared or the sum of just a variable. And note that these summation formulas we can use, they start at 1. So this one needs to be rewritten a bit. So check this out. I'm going to write it as the sum from j equals 1 to 34. But we'll have to remember that's not our problem. So we have to make an adjustment to make it equal to the problem we start with. Okay, so that is going to be bigger than the problem I started with, right? Because this starts at j equals 2. That means plug in 2, see what it is, then add to it the result if you plugged in j equals 3, and then add if you plug in j equals 4. So if we go to j equals 1, then what we have is something that's not equal. It's actually bigger than what we have over here. So we got to back it up. We got to take something out of it. And what we're going to do is we're going to take out what it is when j equals 1, because that's the extra piece that we just added into the summation formula. So if we subtract it from the formula, then we'll be equal to what we have up here. And if you plug in j equals 1, then you got 1 squared is 1, 4 times 1 is 4, 4 divided by 3, that's 4/3. So 6 plus 4/3. I don't want to write it as a fraction, but I think I have to. It's 18 over 3 plus 4 over 3, so that's 22 over 3. So we can wait and use that at the very end of our sum. Okay, so now we fix that part. Now our formula starts at 1 like they're supposed to. And now the summation operator acts like a linear operator, which means it can break up to each separate term like this. Gotta find better surface here. Okay, that's much better. So I'm doing the sum from j equals 1 to 34 of 6j plus the sum oh my gosh, there we go. That's as good as it's going to get. J equals 1 to 34 of 4j squared over 3, and that's still being subtracted by 22 over 3 at the end. Okay, so that's one cool property of the summation operator. It's like the distributor property. And then another part is that if you're multiplying by a constant, just go ahead and factor out that constant. Then over here, we got 4/3 I'm going to factor out. I don't know why, but the second one I can't do it. So I factored out the 4/3, so I'm left with j squared. And now all that's left to do is to plug in our formulas. So 34 is like our n in this formula up here. So I'm doing 34 times 35 over 2. So this is the 6 that was left over times 34 times 35 over 2. I have to use that formula. J squared just has a bit of a longer formula. 34 is my n. That's the top part of the summation. So I'm plugging in 34 times 35 times whatever this is going to be. We don't want to forget the 4/3. So it's n times n plus 1, so that's 35. And then in the third part, the second parentheses there, that's 34 times 2 is going to be 68. 68 plus 1 is 69 here. Hope I did that right. And it's all divided by 6 for that formula. Okay, and now it's just arithmetic. But if you do that out slowly, using common denominators whenever we have to, should get the right answer. All the crazy math stuff should be done. So 3570 for this term. 34 times 35 times 69 divided by 6 times 4 divided 3. That doesn't count even. So. Okay, let me just 34 times 35 times 69, divide that by 6. The formula part should always come out to an integer. So I'm multiplying that to the numerator, so that's 54740. And we weren't able to make it come out to an integer when we divide that, so we'll leave that as a fraction. Okay, but luckily these already have common denominators, so we can subtract those numerators. Is that divisible by 3? 9, 16, 17. No, it isn't, so we're going to have a messy, yucky, no good answer. 54718. So we need common denominators, so multiply this by 3. 10,710 over 3 plus 54718 over 3. Now when you add the numerators, 65,428 over 3 is what I got.